The new ultra laundry monitor can be possibly the future of radiation measurement equipment in facilities like cyclotrons, nuclear research establishments, and nuclear medicine in general. The unit has been designed, and because it's possibly the latest, include microprocessing power, which hasn't been included in another unit currently on the market. The design is conventional as any type of luggage conveyor belt type, but the detection that we have incorporated in the system is quite unique. So we will do a preliminary introduction to the system. The unit is extremely easy to operate, so doing training or introduction to the system is not that easy because there's not much to say about the system except that it does the job how we want it to be. So, by beginning, we will say we have a laptop that is programmed with a software package included the picture of the unit as well. So it's very obvious and simple to operate. It shows 3 different channels, which are the 3 different channel scintillators. But those scintillators, again, they're being divided in 3 more channels. So in total, there is 6 channels that feed the information to the actual unit or to the computer. The scintillator being composed, that it's got detection at both ends, so we can get the maximum performance of the plastic scintillator. On top of that, the scintillator has been coated with zinc sulfate. In doing that, we can detect alpha, beta, and gamma. The thickness of the stopping power to stop the gammas is 20 millimeters. Therefore, we have sufficient stopping power to be able to stop gammas penetrating the detector and achieve scintillation. We are going to start by starting the unit. So here we have the gantry of the unit, and is where you introduce the product. And is where you receive the product. If the detection of radioactivity is introduced through a garment, the unit will receive the unit through the gantry and it will return it back to the entry. It will not allow the unit to continue the journey to the other side. The input to the unit is by those switches at the bottom, which is they got a fuse and line and circuit breaker, and an output to the laptop. The laptop located anywhere in the room or in a desk can be easily controlled to demonstrate the performance of the unit. Okay, here we have the demonstration given by Brian on the beginning of the software, how to start the system, and he just rebooted the computer purely for our demonstration.
Then it will take you to the main software. So this is the main screen. Say there are 3 detector sections: left hand side, top side, right hand side. Each section will show the background level, alarm threshold value, then current reading. Then the bar graph will indicate the how much the radiation is present. Then if you go in the middle of the section, you can select radiation detection mode selection here. There are 2 modes. First one is normal mode, which is unit will take the garment, then it just pass through. So if you have big through output, then there is no delay in this. You can use this mode. But if you want to use this unit as detecting very low activity and maybe alpha and beta mode, then you may use delay mode. So by selection of this radio button, it can change, but very simply. So once the mode changes, there's confirmation message here, delay mode activated. If you change over to normal mode, it's gonna show here. So now the normal mode activated to startup. So the software on startup, it will measure the background for 30 seconds, which is factory default. Then it's gonna show up on the individual detector section. And what it does, while the unit measuring the current radiation level, it continuously subtract the background. Then we just compare with the real activity and the measurement. So now ready to use the system. Say just underneath there, we have 3 buttons, which is the conveyor belt control section. So you can run reverse, belt, stop, and forward. To start up, you basically click the forward button, like that. Then the valve starts running. Now ready to use.
On the desktop,
The simulation LDM icon here, double click, then you have the simulation software here. To simply press auto connect, what it does, software will search the hardware, then the handshake, then will set the communication up. So I press auto connect. Now it says phone. Now just activate auto polling, and you start receiving the data. So you can see what's going on between hardware and PC at the moment. So if you want to check the high voltage on the channel 1,
well, let me get to that. Channel 1, yes.
just select device address number 1, then press read button. Then it
Which
says
button was that?
read. Yeah.
Read button.
On the hardware high voltage section.
Okay, 1044.
Yeah.
Now, is that for individual channel or individual PNT?
Yeah, this is the PMT.
PNT. So
We have
if I want to look into all the PNTs, how we do the
Change-
measurement?
Change the channel.
channel address 2.
So you go to channel 2.
Yeah, then
And then this button.
Okay. So now you're in channel.
2. Then press button.
The unit is oscillating there. 2. Okay.
Yep.
Okay. Now it's changing from 2 auto pulling.
Yeah. So computer to pull the data from channel 1 to 7. Say yeah. Channel 1 to 6 is detector part, and 7 is for the controlling part.
Okay. All right. So now to check another channel, say channel 3.
Yeah, at the moment channel 3. Press the button. Yeah, the same setting. Then even you can check the sensitivity. And 197. This section we're gonna give you the additional information in
Yeah.
writing.
Okay. Now the manual that is being created for that is the preliminary manual that we have. Okay. All right. So the unit is finished in reality and is ready to go. Okay. Give us a demonstration on putting the unit to normal functionality.
So it's the background again.
The unit will do automatic background subtraction. So the situation is with this unit, even if the background, the normal background, is higher because this is a situation in this facility, being a radiation area, will have a background which is slightly higher than the normal. The unit still have the capabilities to subtract the background and adjust the cell automatically to the measurement. So the alarm is being set up to 100, as you can see here, on the drill, alarm value to 100. And the unit, when it reaches 100, even if the background is higher, now we got 3 different detectors. Remind you, this is very large scintillators. which are extremely sensitive. For that reason, the background measurement that they collect is much higher than the normal scintillator crystal type of sodium iodine. So in view of that, our background is extremely sensitive. So in doing that, the unit have subtract the background. As you can see, the alarm should be going off if the background, the alarm, it pins it up to 100 and the background is 190. So the three scintillators are very close, and that is purely different to different voltage. They can be adjusted a little bit better, but that's good enough, because you're not concerning about the background so much. You're concerning about, is the unit capable to read 100 becquerels, and that's what we are more concerned about, because that's how the unit calibrated. So now Brian is going to do a demonstration, which is basically get the unit to operate. It's got a white gown here that is going to put to the gantry without any radioactivity whatsoever.
Yes. Start measuring.
Okay, so he's activating the unit in the manual mode, and the unit has a gamut passing through. Now there is a delay here to show that the unit is measuring and to see if it picks anything related to radioactivity. And then manually you can get it to move if you require. But if you set it up at automatic, the unit doesn't need to have any movement whatsoever or implications from a human. It can be always done automatically. Okay, Brian had done some adjustments there. And to demonstrate again, the unit will be put one more time. The measurement on the unit is 0. Okay, now what Brian is going to do is to load in the gamut a tiny little check source, which are very, very low in value. So this is almost indetectable into any radiation. So the situation is that he has added that. Now background has changed a little bit in the room, simply because that detector that he's got there. Right, so what he done, can you do that again, Brian, so to show to how the source you got there? I'm just going to zoom into the source to show, and zooming into the source to show it's a tiny little crystal source. It's normally used in schools to demonstrate how radiation works in Australia. Okay, you're going to put it in the pocket gamut, then fold it and introduce that through the gantry.
The whole thing from the distance to see the action, and that's what actually happened. So the unit now is returned to the original position, so it doesn't pass the test. So the radiation was detected in the unit, and the alarm has gone off.
Here we are using a gate source of Americium 241. Basically, when I said this source, it's from the smoke detector. The activity is very, very low. It's less than 0.9 microcurious. So these sources, they are installed in every smoke detector around the world. They are not considered harmless because they have an alpha measurement capability, alpha emitting capability, and they have a little bit of gamma. Okay, here we will try the plastic. We will try. This is very interesting. What we've done here. Give me that one again. As you can see, this is the sine source basically of Americium 241, which has been used just purely for calibration because they are very long life sources. Although they have a 70 keV energy level,
these sources they last 490,000 years to 490 years. So, well, that is a very long life type of source. Now, when we put it to, can you activate the unit? When I put the unit in the actual detector, because they got a very low life and set therefore it's called detector, we're only getting it's a barely a reading. But here we got the tiny little source again by itself, smoke detector, design product, and we put it in front of the detector here. We should get a reaction. 34 kV, 48 kV, and he goes into alarm. Now, it took a little bit of time because it's alpha, basically, what it's seeing. And we can try the other scintillator as well. And we do the same thing with the other side of the detector, trying to get closer to the center. And we get in 88, and then alarm. Now, these sources are highly detectable by any type of radiation detector. So, to go to the lowest as possible, we have used something that you don't need. This is something which is so low. It's got an energy of 70 kV, and as I said, very low, inclusive the energy by just putting plastic, which is sticky tape in front, you can't detect it anymore. That's how low the actual activity on the sources are and the energy. Okay, so if I put plastic in this one, it will be the same. We can even do the exercise by trying it with a pancake detector, just to show you that if we put the sticky tape on, it will not be able to be seen. And that demonstrates how sensitive the current detectors are. Stop. I have a very sensitive thermometer which is designed for Japan problem, and it's called the Fukushima. It was specifically a product that went to Japan, and the first production was actually taken by the Fukushima reactor. This unit allows us to do many little experiments. The unit is calibrated to chloride 36, which is again a very low activity beta energy. And here, for example, say we have put a piece of paper in front of one of these tiny americium sources, and what we get in here is 0.1 microsievert, which again is nothing, and that is basically the gamma. Okay, now what is going to happen, I'm going to remove the paper, and that's going to give us an exposure to the betas and the alpha that exist in the tiny little source. And as you can see, immediately the line goes above, because now we are detecting alpha, beta, and gamma all at once, giving us a total value of 102 microsieverts. So that is 1/10 of a millisievert. Okay, so the other source that we have already with plastic in front, again, should be able to buffer by less, and gradually the meter drops. And that's it.